Good morning. Today discuss about the proof of some identities. Okay, we are going to see the proof of some identities. That is proof of a plus b the whole square equal to a square plus 2ab plus b square. Then a minus b the whole square equal to a square minus 2ab plus b square. Then a plus b into a minus b equal to a square minus b square. So we are going to see the proof of all these things. These things can be simply obtained by multiplication, a plus b into a plus b, and this is a minus b into a minus b. If you multiply these two, you will get the formula a plus b the whole square, but that is not the thing we are going to provide here, because that you know very well. If I tell like that, that is not the proof. That is derivation of these that is derivation of the product of two terms, a plus b and a minus b. Okay, if I want to give you the proof, means what is the proof? Because the mathematicians did not simply present the formulas. All the formulas are having some reasons and meaning. So the meaning can be derived, but reasons should be proved. Okay, it should be a proven result. Okay, so for that, see, mathematicians in a real life scenario would have faced some problems, and they thought it would be very beneficial if they simplifies the solution in such a way how they had solved a problem and presented it in identity form to solve the problems that arise in the future. Okay, so they are having some problems and they derived a solution and they simplifies the procedure of obtaining the solution to that real life problem, and after that they present us the formula. So formula, first of all, they did not create a formula to solve the problem. They solved the problem in a traditional way without using any formulas. Okay, and after that they simplifies the traditional very long procedures into simple one line identity, and one line identity is called formula. So these identities have been derived by the mathematicians once upon a time long ago, because of the real life problems they had once. That will be the scenario. So we are going to see how they could get this. Okay, now we are also trying to get the same result. If we are the world mathematicians, how we think. Okay, that is the story, that is the idea of today's video. Okay, so just simply watch me. Now I am taking a square. Now I am simply taking a square. The square is having, see, it covers only one box, it covers two box, it covers three box, it covers four box, it covers five box. Okay, it covers five box now. Okay, it covers five box now. So in the row I am having 5, in the column also I am having 5. So length equal to 5 and breadth equal to 5. Length equal to 5 and breadth equal to 5. In this you are having the equal split ups, that is called scale. That is called scale. The equal split up. Okay, the equal split up inside a square figure. Okay, if you are taking a rectangular or square figure, you can divide the region into number of equal split up, that is called scale. Okay, so because the scale looks like a rectangle. Okay, so in that you will have, this will be the this will be 1 centimeter, and here you will have the 1 centimeter split ups. 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter in the scale. So you will have 0, 1, 2, 3, 4. So it covers 1 centimeter breadth always, and 1 centimeter in the breadth. So you can split this to derive the total number of split ups in any rectangular figure. Okay, so that is the purpose of scale. So in this we can say that each box is having, or in x-axis it will consume approximately 1 millimeter. Okay, so see 1, 2, 3, 4, 5. Here also the breadth 1, 2, 3, 4, 5. So scale will be in x-axis 1 millimeter equal to 1 unit. In y-axis also 1 millimeter equal to 1 unit. Okay, 1 unit. So you have to watch my words very clearly, since my writing will be very small and sometimes it may be unclear. Okay, 1 unit. Where this is in x-axis and this is in y-axis. Okay, so here you are having 5. See, there are 5 boxes, then again 10 boxes, then 15 boxes, then 20 boxes and 25 boxes. So when you split a row and columns into 5 equal split tabs, okay, I am taking 1, 2, 3, 4, 5 in the row, and 1, 2, 3, 4 and 5 equal split tabs in the column. You will have 25 boxes or 25 intersectional areas in between these two regions, these two lines. Okay, that is what we are having, that area. Okay, area means intersectional areas that is produced by the intersection between length and breadth. Okay, so if I suppose to take length as 5, if I suppose to take length as 5 and breadth as 6, see, just a minute, if I suppose to take see, now I am having 1, 2, 3, 4, 5, 3, yes. Now this is a rectangle. See why this is rectangle means I am splitting the length. L equal to 1, 2, 3. See, 1, 2, 3, 4, 5, 6, and the breadth into 1, 2, 3, 4, 5. Okay, so L equal to 6 and breadth equal to 5. So this split tab gives you 1, 2, 3, 4, 5, 6. So 6, 12, then 18, then 24 and 30 will give you the 30 equal boxes in between. That is, area will be 30 units. This is 25 square unit and this is also 30 square units, because length is also a unit, breadth is also a unit. So you will have 30 square units. So this is called square and this is called rectangle. If here b equal to, that is breadth equal to 5, sometimes you can take length equal to 5 and breadth equal to 6, which will also give you the same rectangle, which will also give you the, if you rotate this figure, you will get breadth equal to 6 and length equal to 5 and you will get the same rectangle. So now you understand the concepts of square and rectangle. So by the square, you came to know that a square is nothing but a into a. and AB is nothing but A into B. Okay, AB is nothing but A into B. Now we are coming to the real necessity of the proof. Okay, now we are going to take these three things. Okay, these three things. Okay, and we are going to prove that. Okay, now assume A plus B the whole square equal to what? I don't know, but I want to derive this. How it can be derived? Okay, now I am assuming a square. Now I am assuming a square. Now I am assuming a square. Okay. This square is called, this square is having the length A and breadth B. Okay, so breadth is also A, breadth is also A, and I know that A into A equal to A square, isn't it? Okay, now I want to extend the size of the length and breadth. Extend the size of the length and breadth. So I am extending this. With green color. See, I am extending the length and breadth evenly. So it covers 3 boxes, and here also it covers 3 boxes. So I am extending this. Okay, see, now I have extended this. So 3 boxes and 3 boxes. So I am taking this as B, this new area, this new extension as B. So already I am having the length A. Now I have added a new length B. Already I am having a breadth B. Now I have added a new breadth B. Okay. So what will be my total area? So you can see here a box. Which is having the equal sides, that is B and B, length B and breadth B. This is a square. And is called as B square. Okay, in the same way you are already having a square. And this is called as A square, and we have written it below. Okay, so this is A square. Okay, this is A square and this is B square. Okay, I think it will be more it will be look very good if I put just a minute, if I put red color inside this, and I am putting green color inside this. See here, already we are having the length A. Now we have added a new length B. Already we are having breadth B, and we have added new breadth B. So the total distance on breadth is A plus B, and the total length will be a plus b. So these two will give you a plus b into, that is length into breadth, that will be the area. Okay, area of a square or area of rectangle. Area of a rectangle equal to L into B. Okay, our rectangle becomes square, so you will have L into L, both, or side into side. We shall simply use side into side. So one side is having a plus b and another side is also a plus b. We can simply multiply to get the result, but that is not we are going to do. Okay, see here. Okay, this is one way, but we are not going to derive the formula in this way. Okay, so if you have such an idea, kindly please remove that idea. Okay, so here you are having a square and here you are having b square. Okay, now you are having two rectangles. Am I right? This is a rectangle and this is a rectangle. These two rectangles are having the side, yes, see this length is a, breadth is b, that is what we have written. And here also we are having length a, length b and breadth is a. So this will form a rectangle AB. Okay, this will form a rectangle AB. So I am writing here AB, and here you are having AB. So this will give you the entire visualization. The entire a plus b, okay, the entire a plus b whole square is having a square, that is called a square, and another square that is called b square, and two rectangles in between these two squares, that is called AB plus AB. So that is a square plus 2AB plus b square. Okay, so we have obtained the first result. So this is the geometric proof of a plus b the whole square. This is a geometric proof of a plus b whole square. Now we are going to take another figure. We are going to now assume once again a square. Okay, we are going to assume a square once again. Okay, now this is a square. I am taking the sides as I shall take red color. Okay, now see, I am taking a square. Okay, now this is a square having the length A and breadth A. Okay, having the length A and breadth A. See, in length A and breadth A. So we know that A into A equal to a square will be its area. But I don't want to calculate the area of this figure. I want to reduce its size. I want to reduce its size to some dimension. So I am only taking a small box. Okay, so for that, see listen here. Listen. I don't want to include these two boxes in my calculation. In the same way, I don't want to include these two boxes in the dimension. Okay, and this small area will be called as B. Okay, this small length is called B and this small length is called B. Okay, now what will be remaining area? See, already I am having an entire area. As a square, which is given by the entire length A and entire breadth B. Now I want to find only a small area that is having a new length and breadth. After subtracting a small length and breadth, a small equal length and breadth called B, I am having this new length A minus B and the new breadth, new breadth A minus B. Sorry, new length A minus B and the new breadth A minus B. Okay, so I think you have copied. So since I want this small area, I am changing the color. I want to find only this. Okay, I want to find only this small area. Okay, I want to find only this small area. Okay, so this is having the length A minus B. This is having the length A minus B and the breadth A minus B. Okay, till this A minus B and also here also till this A minus B. Okay, this blue color only will be A minus B. Okay, now it is having, now we are going to remove all the other things. Like this green color and two rectangles. We are going to remove. So okay, so before we are removing the other figures, we shall find the area which we are removing from the A. Okay, so see here the length is A minus B. Here the length is A minus B. Length is A minus B and breadth is B. So this rectangle is having the area A minus B into B. Here the length is the length is, in this you are having length b and breadth a minus b. In this you are having length a minus b and breadth b. So this rectangle will have a minus b into b, length into breadth or breadth into length. Okay, here both length and breadth are equal, that is b into b. So this forms a square, that is called b square, and here you are having a minus b into a minus b. This will form you the square a minus b the whole square. This will form you a minus b the whole square. Okay, a minus b the whole square. Now I want to calculate only this a minus b whole square from the entire a square box. From the entire a square box, I want to remove this rectangle and this small square. I only want to find the remaining this square. Okay, now for this I want to write the entire area first. What is the entire area? The entire area is a square. Here the box a square is having, this is the box a square, no? So the box a square is having a square called a minus b the whole square, that is this, and a rectangle a minus b into b and a minus b into b plus a minus b into b plus a minus b into b plus a square, another square, that is green square b square. Okay, now this will be given by a square equal to a minus b the whole square plus this will become, these two things will become 2 into a minus b into b plus b square. Okay, now I want to calculate this a minus b the whole square. So I am writing a minus b the whole square equal to, I am taking all other terms to the opposite side. So we will have a square minus 2 into a minus b into b minus b square. Okay, so which will give you a square minus 2ab then plus 2b square then minus b square. So which will give you a minus b the whole square equal to a square minus 2ab, 2b square minus b square is plus b square plus b square. Okay, now you got the idea how the mathematicians derive these formulas, how a plus b whole square become this and how a minus b whole square become this. Okay, now dear students, now we are going to find the third identity, important identity, that is a plus b into a minus b. Okay, a plus b into a minus b. Okay, we don't know what is its right hand side, so we are going to derive this. Okay, so now for this I am going to consider a square. For this I am going to consider a square. This I am going to consider a square. See, this is a square. Okay, and this square is having the dimension, this square is having the dimension a and a as length and breadth. So L equal to a and breadth equal to a. So we know that a into a equal to a square. Now I am going to convert this square into a rectangle. I am going to convert this square into a rectangle by adding two more boxes. Okay, by adding two more boxes. Okay, I am adding two more boxes. Okay, this new side is called B. This new side is called B. Okay, this new side is called B. Okay, actually in the length I have added A and B, but in the breadth I want to subtract this breadth, this length B. So I am going to subtract the same B units. I want to subtract the same B units here. Okay, this is B. I want to subtract. So this is called A minus B. This is A minus B. This is A plus B and this is A minus B. Because I want to find the area of this. Okay, I want to find the area of this length and this breadth. Okay, I want to find this. So for that I want to create a formula. So I just only want this side. Okay, I don't want the unshaded region. I don't want the unshaded region. Okay. Okay. Now what is this side? What is this side? See, this length, this new length is A plus B and this new breadth is A minus B. So I want to find A plus B into A minus B. So here there is a square called B square, and but we don't want that. Okay, and here there is a rectangle and we don't want that also. Okay, we only want this rectangle. So how I can represent the same rectangle another way other than this A plus B into A minus B? In what way I can represent? That is, I can represent this as, see this is called the original length I am having is A plus B. The original I am having is A plus B and breadth as A and breadth as A. Am I right? So is it right? No, it is not right. This is A minus B and this is A. So I am going to split this into two half. I am going to split this into two half. That is see here I am using yellow color. Okay, this small square or this small square is called, what is this? This small a square or rectangle? This is a small, this is a rectangle because the length is A, the breadth is A minus B. This yellow color will give you this yellow color will give you the length as a, okay, the length as a and the breadth as a minus b. Okay, now the remaining side this, and for that I am using pink color. So that will give you length b, breadth a minus b. That will give you length b, breadth a minus b. That will give you, see here, length is b and breadth is a minus b. So b into a minus b. Okay, so we can write that the area of total rectangle as sum of a into a minus b plus b into a minus b Okay, so it can be found very easily that a into a is a square minus ab plus ab then minus b square. So these two terms will get cancelled. So you will have a plus b into a minus b equal to a square minus b square. Okay, a plus b into a minus b equal to a square minus b square. So this is the result. Okay, some of you may think we can derive the formula from the second figure itself, since we are having a square as well as b square. Some of you will think like this. Since we are having a square and b square, we can derive the formula from there itself, but it is not possible to derive the result from the second figure because it will again give you the second formula and not the third formula, or that is not a square minus b square, because you can see here, if I write a square and if I take this b square to the, if I take this b square here, see here, if I take this b square here, a square minus b square, I should get a plus b into a minus b, but it will not give that. The second figure will not give you that result because a square minus b square, from the second figure you will have a minus b the whole square, okay, minus 2ab then minus 2b square, okay, that is equal to a square minus 2ab, okay, it is x plus 2ab plus 2ab minus 2b square. These two will get cancelled. Here you will have another b square. So it is a square minus b square. So in left hand side also you are having same a square minus b square. In right hand side also you are having same a square minus b square. So it is not possible to derive the third identity from the second figure. So I hope you understand the geometric proof of, or the visual proof of, three formulas: a plus b the whole square, a minus b the whole square, and a plus b into a minus b. Okay, so I hope you all understood the formula very well. Kindly share this video to the young children who are doing higher educations, high schools studies, that is 7th, 8th students, because in schools, many of the schools, the students are memorizing the identities. It is not necessary to memorize. If you understand the concept, you will not forget the identities or formulas. Okay, there is nothing to memorize in this. The only thing is you have to understand. Okay, the best way of solving a problem is to solve it. The best way of practicing something is to practice it. The best way of doing a thing is doing. So there is no other alternative way to achieve it. Okay, if I want to do something, I have to do it. There is no other alternate way. So if you want to understand a concept, you have to understand it. You have to try to understand it. Unless you will not understand it. Okay, unless you try, it is not possible to understand. So don't memorize the formulas, just try to understand. Thank you all for watching this video. Thank you all once again.